Hey guys, so hopefully this video is going to upload. I guess y'all got my message that I sent you this morning about the other videos. Or actually, I guess you're listening to this on Wednesday, so it was yesterday morning. But anyways, still they haven't showed up. I don't know what has happened to those videos. I cannot get them to load. So I'll just go over that part when I'm back with you either Thursday or Friday. Alright, so we're just going to keep going on lesson 2.3. We're going to finish it up here. And so it talks about the intermediate value theorem. And so basically this theorem just states that if you can find two y values where the signs change, so one's positive, one's negative, then there has to be a zero of the function in between the two x values that gave you those y values of the function. So you can see here, like we have x that's a and x that's b. And so I guess let's do this one here. At a, we have an ordered pair on our line there, the blue line, of a comma some negative y. And so then we have point B, and up there on the blue line, we have the point B comma, and that's some positive y. So because my y's went from negative to positive, that means in between them, I have some point C here in which there is a zero. And so that's all the intermediate value theorem says, is if you can find two x values where one of them has a positive y, one has a negative y, then there has to be a zero in between them. So let's look at the next example. So example 4 says use the intermediate value theorem to explain why the function g of x equals x squared plus 3x minus 6 must have a root, which is an x-intercept, on the closed interval from 1 to 2. So what we need to do is find what g of 1 is and what g of 2 is. So let's find g of 1. And so I'm build my skeleton here. And I'm going to plug in 1. Work that out. And I believe I got negative 2. Then I'm going to find g of 2. Same way. I'll build my skeleton. And we got positive 4. Now because one of these had a negative y value and the other one had a positive y value, that means in between where x is 1 and x is 2, there exists a 0. There's an x-intercept between those two. So it said to explain it. So by the intermediate value theorem, we're going to abbreviate it IVT. There exists a value x equals c, where when we plug that c value into our function, so f of c is equal to 0 on our interval from 1 to 2. And that's because when we plugged in g of 1, we got a negative value, and we plugged in g of 2, we got a positive value, so g of 1 is less than g of 2. One of them was positive, one of them was negative. So, and it wouldn't matter. If the first one had been positive and the second one would have been negative, there would still be a 0 in between them. It would just be that our function would be decreasing instead of increasing between those 2 points. Alright, so that's the intermediate value theorem. That's not too bad. It's usually pretty easy to find, so hopefully we'll be good with that one. So let's keep going. Let's talk about concavity and points of inflection. So, looking ahead to calculus, we need to explore concavity. Our goal is to understand the terminology for now. Later, we will have calculus rules for finding these intervals algebraically. A function f is concave up On an open interval I, if for any choice of x1 and x2, with x1 being less than x2, the graph looks like a U or part of a smile. The tangent line will be below the curve if the function is concave up. Shade the graph at the right in green for this behavior. Okay, so if you don't have green, that's okay. Just pick some color or something that you can use. Alright, so concave up. So we're going to assume our graph just keeps going up to the left here, okay? So this right here would be concave up. Just making that smile that it talks about. And to some point somewhere in this area. Okay, and then from there it'll switch to something different. So then it says, I can't read all of that, so dang, I'm going to have to move my graph. Okay, let me do this. I'm just going to minimize or zoom out just a little bit there. I'm going to zoom out a little bit more so I can see the rest of it. Alright, so let me recolor real quick that green. So we said that it came from here, it goes around to some midpoint there, right? And we had said that this was, this here was concave up. Alright, so then the next one says that a function f is concave down on an open interval I. For an open interval I, if for any choice of x1 and x2, with x1 being smaller than x2, the graph looks like an upside down U or part of a frown. The tangent line will be above the curve if the function is concave down. Shade the graph at the right in blue for this behavior. So we can look at it and we can see where our frown is at. So it's from some point midway here, and it's going to come up and then it's going to come back down, and we're going to assume this graph keeps going down. Then it says a function f has a point of inflection at C. So it has a point of inflection at C on an open interval I if the graph changes concavity. The tangent line will be above the curve on one side of C and below the curve on the other side of C. Draw an estimate for this point in red. And so that's pretty much what I had just drawn here. This point where it's switching from concave up to concave down, that right there is your point of inflection. Alright, so let's check out some more stuff. It says use the graph shown below to complete the following. Yeah, I can squeeze it up here enough to see it all. There we go. Alright, so we want intervals of increase. So we've done this before. Increasing is just where it's going up. So I can see here from D up to here where my x value would be E. So from D to E. Did we have anywhere else that was increasing? Well, right here from F to G. And nowhere else. Then it wants intervals of decreasing. So remember, decreasing is going down. So let me erase my red points there. Alright, so it's going down right here at the beginning from when x is A to B. And is it going down anywhere else? From when x is E to where x is F. Remember, we always name these by their x values, and we always use parentheses. Some of y'all did not get that on the test. Anywhere else that it's going down? Well, look here, from G all the way to, we'll say H. Really, I guess that would be right there, which they're saying is H. So from G to H. intervals of constancy. So where is it constant at? So remember, constant means the y value doesn't change. It's the horizontal line. And so we can see right here from B to D is where it's constant. Alright, D says the mark and estimate 2 points of inflection, K and M. So remember, points of inflection is where it's changing concavity. So, let me get rid of these purple marks. And so we can see that it's changing concavity somewhere in here. So we're going to call this K. And then somewhere in here where it's M. Remember, it's where it's changing from concave up to concave down or vice versa. It's where you're looking for your smiles and your frowns. So, we did that. It says that where is the graph concave down? So let's see, it's concave down right. Well, let me change colors there. I'm going to leave those points there because it wanted me to. So I can see that's concave down right here. So from D to K. So D to K. And it's concave down from M to H. So M to H. And then find where it's concave up. Let me erase these and try not to erase my points of inflection there. Oops, I erased some of my K there. Alright, so where is it concave up? So it starts here at K, and it's going to go over here to M. So from K to M. And it wants to know relative maximum values. Remember, that's our hilltops. So I have a hilltop up here at x equals E, and right there at x equals G. So relative maximum values are at, remember at means x equals, so we said it was E. I'll just put and x equals G. And then it wants to know the minimum values. Well, remember minimum values are the valleys. So go find any valleys that you've got. And we have a valley right here when x is equal to f. Alright, so that should conclude 2.3. You may have some little bit of issues there at the beginning, but don't worry about that. We'll just go over that together then tomorrow, or tomorrow together, whenever I see you next. And we'll cover it, and I'll also plan on going over that homework, some of it on 2.1. I know a couple of y'all emailed me about the word problems, and that is in one of those videos that did not upload, so I will go over that with y'all as well. Alright, so if you have any questions, let me know so that I can be prepared for the next time I see you, and I will see y'all the next time. Bye.